Alright, in part one of this video series on free body diagrams and representing forces with vectors, I reminded you of the idea of a vector, and then we went about labeling things that are interacting with an object, in this case that balloon, and then introduced the idea of the free body diagram, our most important representation for the unit on forces. We had gone about and drawn our balloon, a representation of the balloon. We had drawn the two vectors to represent the two interactions with the balloon, and then we'd gone ahead and labeled those. And I believe that I had explained this labeling as force, spring on balloon, and these two give us the two objects that are interacting. So now I wanted to come over here and talk to you about this. So here we have, this stands for the earth interacting with the balloon. So again, this double subscript notation tells us what two objects are interacting, and for that reason it's important to use that double subscript notation. Alright, now what does the W stand for? The W stands for weight. And weight is the name we give to the interaction between the earth and some other object that's near the earth. In fact, it could be between any planet and some object on that planet. So the word weight specifically refers to a gravitational interaction between a planet or a moon and some object. That's what we mean by weight. The weight of an object is related to how much matter makes up the object and how big the planet is. But for our purposes, we understand the sense of weight as being the sense of being heavy. Alright, so that's the free body diagram notation there. Alright, now what I'm going to do is to grab my balloon here. We'll go over and get a new page. And let's take this balloon contraption and let's draw another free body diagram. But this time let's draw it of the spring. Alright, so what's interacting with the spring? Alright, so first we have the platform. We also have the earth, and we have the balloon. Those are the three things that are interacting with the spring. And so now what I'm going to do is draw a free body diagram of the spring. So here is a box representing the spring. The earth pulls down on the spring, and so we're going to say earth, weight of the spring, which is the earth interacting with the spring. And we have the platform pushing up, and then we have the balloon pushing down. Force balloon on spring. Alright, now what to name this one? Well, if you refer back to the sheet on named forces, where I also introduced the concept of weight, you'll notice that there's a certain interaction which we call a normal interaction. Normal means perpendicular here, not sort of average. And so this surface exerts a force upward or perpendicular to itself on the spring. And so we call the interaction between the platform and the spring a normal force or a normal interaction. Again, it doesn't mean average, it means perpendicular, perpendicular to the surface. So here's a free body diagram of the interactions with the spring. By saying that we have no idea about the sizes of any of these interactions except for one, and that is that and that are the same size because they are in fact the same interaction. Spring on balloon, balloon on spring, exact same interaction. And that's the end.